Go away. So section 3.3 is going to deal with two different topics. They're really, for the most part, unconnected. They just happen to be in the same section. Percentiles and box plots. So let's look at percentiles. I'm going to put everyone on mute, if you don't mind. There we go. Looks like Denise is getting the full picture again. Hi, Denise. I have no idea why it's doing that. Maybe I click on me. There we go. I don't think that's an improvement, but at least it's not you anymore. Yes, I was here to put things on mute, which I have. So you'll hit the space bar when you have to answer a question or whatever. There's a fair chance that you've actually seen percentiles. You know, if you do your SAT, you might get a particular score. Right, I get 520 in my math SAT, you know, that kind of thing. Do you know you will also be told a thing called your percentile? Or you should. Let's suppose that I did the SAT and I was the 87th percentile. That's one way of phrasing it. 87th percentile. Can you imagine that this was all the SAT scores that people could get? And it looks something like that, because that's typically what all tests look like. So if you were in the 87th percentile, you were about here. And what that means is that 87% of the people who did an SAT did worse than you, right? Got a smaller score than you. And I guess if you look at it from another perspective, weren't there 13% of the people who took the test got a better score than you? Now, a percentile tends to convey better information. I don't even know off the top of my head what a SAT score is, but if you told someone you got a 520, for argument's sake, is that good, average, or bad? Can you see? You can't really tell unless you know lots of other things, like what's the average SAT score? What's the best score you can get in SAT? What's the worst score? Because I believe you can't get 0 in an SAT score. Even if you got all the questions wrong, I think it's designs that you always get something. You know, you put your name, right, you're going to get something. So that's the raw data. The percentile is much more useful, because if I say I'm the 99th percentile in the SAT exam, can you see that I could probably get into most universities? Because one of the things that universities use, not the only thing, some don't, isn't they use your SAT score as a guide to who they're going to accept and who they're not. So they use the percentile value as a guide rather than anything else. So I'm going to show you the 3 questions, that's all there is, on the homework that deal with percentiles. And that kind of percentiles done. It's not a big topic, not a lot in it, but it's kind of important nonetheless. Okay. Angela took a general aptitude test, like the SAT, and she is in the 85th percentile in accounting, so it was an accounting exam, I guess. What percentage of the scores were at or below her score? This is how easy this question is. 87. What percentage were above her score? 13.
Isn't it 85?
Because I can't count. I was using my numbers from the earlier question, but thank you for correcting me. You're quite right. We're going to just go through these. The town of Butler, Nebraska, decided to give a teacher competency, can you say the word? Teacher competency exam. I think I might fail it on vocabulary. And they defined a passing score as those in the 70th percentile or higher. Okay. The raw test score was somewhere between 0 and 100. Okay. Was a raw score of 82 necessarily a passing score? Now, what that's trying to tell you is the raw data for your SAT doesn't, the number that you get does not reflect your percentile. Couldn't you get a raw score in the test of 82, but not be in the 70th percentile or better? How would that happen? Well, can you imagine lots of people get lots of good scores?
Yeah, it's possible. You could even have had 99 and everyone else got 100, and you would still not be in the 70th percentile.
See? So what they're just trying to convey to you there is that the raw score, the number for the raw score isn't a reflection on what the percentile would be, right? So yes, no, that's that one. And the final question then. Clayton and Timothy took different sections of an intro to economics class. Each section had a different final exam, it's not a surprise. Timothy scored 83 out of 100, and he was ranked on the 72nd percentile. And Clayton scored 85 out of 100, but his percentile was 70. Okay, there's a lot of information there. Who performed better with respect to the rest of their class? So Clayton got one and Timothy got the other. Who did best? There's a lot of information there, but who really did best?
Timothy.
Because
his percentile is higher.
That's it.
The question is with respect to the rest of his class.
Which is fine. So that's why you could do that, right? So if you were comparing two classes, can you imagine one had a really difficult final and the other had a really easy final? Could you imagine that there would be a disproportionate number of people who got 90% or better in the exam, but their percentile could still be quite low? You know, I could get 90 in an exam and be in the 10th percentile. How can that happen? Well, everybody else virtually got 91, 2, 3, up to 100. That's how it can happen. So percentiles are a better reflection on doing it. Some universities try and cope with the fact that how do you get fairness in grading when 2 different or 3 or 5 different professors are all teaching the same class with different degrees of difficulty in the exams and all the other things that go along with it. And one of the simplest ways they can do that is by using percentiles. See, if you're in a really difficult class, you might get quite a low score, but couldn't that still be a high percentile compared to everyone else in your class? And that's how they can do it. They could say something simple like 90th percentile gets an A, 80 to the 89th percentile gets a B, and so on and so forth. Now, if you do that grading system, in a way, doesn't it not really matter how hard or how easy the exam is? Doesn't it just matter how well you did compared to everybody else in that class? Which is at least a little bit fairer, isn't it? So that, if you're thinking of a use for percentiles, that's one of them. And now we're going to return back to the second part of today, which is the major stuff. And we're going to look at a thing called a box plot. Oh, I was too quick. Are there anything that I've said in percentiles that you'd like clarifying, or are we good? Okay, so now let's look at box plots. Box plots are going to look like this. This is an example of one. We're going to draw diagrams that look like that. They're sometimes called box and whiskers. I like that name better, but box plot will do. And we are going to find out how to make them, how to draw them, and how to compare them, and how to get information about shape from them. So that's kind of the theme. So before we even tackle that, to be able to draw a box plot, you need some information that's called the 5-figure summary. And the 5-figure summary is made up of 5 numbers. They are the minimum, the smallest score you got. A guy called Q1, another guy called Q2, which we would call the median. That one we know about. Another guy called Q3, and the maximum. So in order to draw a box plot, you need these 5 numbers, because these 5 numbers are actually going to tell you where these go. That guy is going to be at the minimum. That guy is going to be at the maximum. That's going to be the location of Q1, Q2, and Q3. Do you see how the median can be called Q2? Do you see how it kind of makes sense in the sense 1 quarter, 2 quarters, 3 quarters, and 4? Right. So let me do a data set where we can work on that. 1, 2, 4, 5, 8, 9, 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, there's my data set in order, thankfully. And we are going to create, I'll use this, we're going to create the 5-figure summary. There's the minimum, 1. There's the maximum, 21. That was easy. Now, this particular data set has 2, 4, 6, 8, 10, 11 numbers in it. Which one of these numbers is the median, the guy we're calling Q2 as well?
Eight.
Okay. Now, if you're wondering where to get it, when there's 11 numbers, don't you guy, it isn't the guy in position 6, the middle. So I'll do it in red. 1, 2, 3, 4, 5, 6. That is the median. Now, 1, 2, 3, 4, 5, 6. Do you see it's the same guy, whether you count from the right or the left? So we now have this fella. Now, when the median, Q2, is one of the numbers, what you do now is you put a wall there. And what that is trying to convey is that that number is, I wish I could bend it a little bit, that number is now gone. And what you've done is you've split your data into 5 little numbers and 5 big numbers. The guy that we call Q1 is the middle of these, and the guy we call Q3, he's the middle of these. But would you agree that the guy that we're interested in is number 4, right? That's the middle of this group. And what would Q3 be?
13.
Agreed. Would you agree these 5 numbers, that guy is the middle? That's called Q3. So we have a 4 that goes here, and finally we have a 13 that goes there. So far, so good. Now, let's draw one of these accurately now. Well, as accurate as I'm capable of doing. Square paper helps a lot here, but I don't really have that handy, so here it goes. You know you're going to start at 1 and finish at 21, so starting at 0 seems reasonable. It's pretty close to 1. I'm going to finish at 21, 2, 3, 4, 5. I'll see what I get. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can you imagine this was square paper and I was actually using boxes to help? So that would be 11, 12, 13, 14, there's 15, 16, 17, 18, 19, there's 20. I've got some room, 21, 22, 23, 24, 25. So you build basically a number line scale, because this is how people are going to read off your diagram. Then you start creating the picture. The minimum number was 1, so you make a little mark at 1. And at the same level, way over here, you put another 1 at 21. Q1 is 4. You draw a bigger line at 4. Q3, or the median, is 13. You draw a bigger line. And Q3 is, okay, Q2 is 8. There we go. Q3 is 13. And then you join these guys together like that. And you join these guys together like that. Kind of cool? Now, this basically tells you everything that you need to know about this number distribution. I know this has only got 11 numbers, but can you imagine this was 1,000 numbers? You'd still be able to create this. You would certainly use software or your calculator if you wish, right? And I'll show you after this how to do that with your calculator. But this here tells us a lot. Can't you look at this and say, oh, the smallest was 1 and the biggest was 21? Can you look at this and say, oh, the middle, the typical score is about 8? And do you see this middle rectangle? Isn't this a kind of reflection of where the middle half of the data is? So roughly half the people got somewhere between 4 and 13. And better than that, the middle half got between 4 and 13. So there's a lot of good information that you can get from one of these. So I'm now going to show you one other piece of information that you can get from one of these. And that is, you can tell, or at least have a good guesstimate, of what the data distribution would look like if you built a histogram. I could get a box plot that looks like this. I could get a box plot that looks like that. I could get a box plot that looks like that. One of these 3 box plots probably came from a symmetric, a mound-shaped histogram, a mountain of data. Which one of those 3 would you say is the most likely to have came from a symmetric mound-shaped distribution?
The first one?
I see 1, and you are right. So I'm just going to put in symmetric. The book would call it mound-shaped symmetric. Now, there's 2 left. One of these box plots came from a skewed right, and one of these box plots came from a skewed left. Number 2, which one did it come from?
That's skewed left, isn't it?
Correct. For those who are not so sure,
on the right side.
say that again.
Because there are more higher values, right?
Okay, that's one way of looking at it. You're right. Oops, looks funny there. I look at the way I look for skewed left is, do you see this long line here? This is the tail. And so I see it skewed to the left, right? Isn't the tail bigger on this side than it is on that? The higher values are over here, but the other ones are there. Okay, so it doesn't take much to figure out that this last one has to be an example of something that's skewed right. So if you collect data and you make a box plot of it, you do not need to do a histogram to decide if it's skewed left, skewed right, or symmetric. Can't you use your box plot to do the exact same job? That seem reasonable? Now, lots of data are not symmetric, skewed left, or skewed right. So what do their box plots look like? Well, this is what they look like. When it's symmetric, aren't both tails about the same size? Isn't the box split in the middle? That's what symmetric looks like. when you're skewed left, isn't the tail big on the left, short on the right? Isn't the box big on the left, short on the right? See, they both match. If you go the other way, big tail, big box, small tail. Skewed to the right, looks like that. Ah, big tail, small box. Big box, small tail. Do you see that they're counteracting each other? They're not in the same direction. That's what random data would look like, right? It's not skewed left, it's just whatever, right? It's just random numbers, no particular rhyme or reason, no pattern. Are we any questions or are we good so far? Denise, do you have a question? I can't hear what you said except one.
No, thumbs. I'm good.
Oh, you're good. That was a thumb. I thought it was a finger. It was a thumb. Gotcha. We are good. So I'm now going to show you how to create a box plot using your calculator. The part that I'm going to use on the calculator is getting the 5-figure summary part. Because once I've got those numbers, I can draw it by hand, right? So you can bear with me for a little while. I'm going to, oops, I forgot I have to do something before that. There we go. And now I can do it. Okay, hopefully you are all looking at the emulator for the TI-84. I think I've mentioned this. If I haven't, I'll say it again anyway. You do need your TI-84 or the emulator version of it for pretty much for the rest of the core, right? So up to now, you could do most of what you needed to do on a normal calculator or in your head, right, for the most part. Some of these questions, you can use the salt button, which basically is software that's doing the same job. But there's a lot of questions that are just a whole set of data. And trust me, you do not want to do standard deviation, for instance, right? By hand, right? You've seen how horrible, tell me you've seen how horrible standard deviation is by hand. Right, you're smiling, you know what I'm on about. So I'm going to get a 5-figure summary, which I'll then use to create a box plot. So we're going to use you lot for data. And I'm going to go edit. And I'm going to have to ask some questions here. Okay. If you are willing to share, will you tell me how many siblings you've got, including yourself? So if you're an only child, you'll say 1. And if there's 2 or 3 of you, you go. So you're going to have to call this out, and I'll just hear it as I see it. Right, so start shouting.
3. 11.
I got a 3.
4.
I'll hit that one. I'm putting 11 as next. Next one.
4.
4. 5. Whoa! Yeah, yikes. I don't know what I did there, but I don't want to do it again. 4. I had 5. I'm going to put my answer in. 10.
2.
Keep going.
3.
3.
13.
13.
1.
Oh, 1.
Professor,
You have a
put
44 in there.
Oh, well, let's show you, because that can happen. If you make a mistake, hit the delete button. It goes away. And then just scroll down to the bottom and type in the 4 that you meant to hit the first time. And let's do a couple more and call it good. Anybody else want to volunteer?
2.
2.
Oh, 2 twice. 2 different people, it sounded. Anything else for a quit?
7.
7 it is. Right, so what you're looking at here is what? It looks like 11 numbers, because that's pointing out the blank. So I have a data set of 11 numbers. Can you imagine it was 27 numbers? Wouldn't you just type them all in? One of the nice things is, do you notice that they're random in order? I didn't need to put them in order. The calculator's going to figure that out for me. I'm now going to hit Stat, Number, move it over to Calc, and choose number 1, 1 variable stats. This should be quite familiar, didn't this? The same thing we done with standard deviation. Q3, well, we did a whole load of stuff. So this is pretty much what we want. I need to hit in blue button 1, and here we go. And there's a whole load of stuff that you might have been using in an earlier section. But I'm going to bypass all that because I only need these guys. So the 5-figure summary that I'm writing down right now is that poor Ripken is an only child. Q1 is 2. The median is 4. Q3 is 10. And the maximum is 13.
Can
I have a
you go
question. Oh,
go
sorry.
Question.
over? I have a question.
Yes.
Can you go over exactly the steps to do that on the calculator? Like what
On this
buttons
one
are you
here?
pushing?
Yes.
Yeah, I have one in front of me. You're just going so fast.
I gotcha. Also, if I still go too fast, watch the video, pause it, watch the video, pause it. But you're right. I do shoot through things far too quick. So here's our calculator. I'll clear that out of the way. Oh, darn it in space. I'm going to have to cheat a little bit here because I'm not going to go through everybody again because I'm not even sure which ones we got. So you got your calculator, you hit the start button and you hit edit. And what you'll have here is all the numbers that people said. So can you imagine I'll just clear these out of the way. I'm just going to pretend that we did it again and it went something like this. Somebody said 13, somebody said 1, I said 10, somebody said 4, somebody said 5, somebody said 6. You just type them in until you get to whatever number you're going to finish. So you hit start, number 1 edit, type in your numbers. That's the big first part done. Okay. Now, this is not going to match this because I just made those digits up, but it'll get you the idea of what we did. Now, once you've got the data in, hit start a second time, move over to calc, and it says 1 variable stats, choice 1, and you hit that guy. On my calculator, I've got a little black flashing cursor. That's telling me I need to tell it where L1 is. So blue button, 1. In some of the modern calculators, what you get is a little menu, and one of the things in the menu will say L1, hopefully. And if it does, then you just hit enter, 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 enter until you get to the end. I think the last thing's called paste if you've got a modern calculator. In my case, I just hit enter. And what we're looking at are lots of statistics, some of which we've used earlier, but I'm only interested in the 5-figure summary. So I scroll down, and there's the bottom 5 numbers, the min, Q1, 2, 3, and the max, which is, in this case, those numbers.
Thank you so much. That was perfect.
Perfect, good. So to finish this question off, I need to draw one, right? So what's happened to poor Ripken? Ripken, are you here? You are. You know when I went and said poor Ripken, do you know what I should have said is that after your parents had you, they figured out you were perfect. They couldn't beat it, so they didn't do any more. And I come from a family of 10, so that probably means my parents weren't too pleased with the first 8. I'm sure they were pleased once I came along, but
I think it's more the fact that I was too much of a hassle and I was a bad kid that they didn't want to have another kid. They're like, oh no, they don't want to have another.
Oh no, we've tried it once. We ain't doing that again. Okay. No, I got you. Well, at least you said that. Someone here said 13. They are so lucky. I love big families. So I hope you agree that having big families are fun. Just family
That was me.
get-togethers.
That
Oh,
was
so
me.
what?
And it's actually my kids, not my
Wow,
siblings.
you have
but
13?
yeah.
Cool.
Yeah.
Well, your kids are going to have a lot of friends as they grow up and a lot of people to visit because Americans kind of wander, don't you? So in
Yeah.
20 years or 30 years from now, there's going to be one of your kids in Texas and somebody's going to be in Alaska and, you know, whatever. And so
Hopefully
just
somebody will
think,
go to like Portugal or somewhere really cool. That would be great. We'll see.
well, you could send one there right now and just farm them off to a relative if you've got anybody in Portugal.
Yeah.
Yeah. That is so cool. I love big families. You don't know what you're missing, Ripken. It's pure pandemonium when you're young. There is no such thing as quiet time.
It's always quiet time here. It's
Right?
nice and it's nice.
I'm sure it is. But when you have weddings and there's 50 people in the hall, or in my case, there's probably about 60 now, and every single one of them is related to you by blood or married to someone who's related to you by blood. It's kind of nice to know that there's a whole gene pool of Robertsons out there continuing the whatever we continue. I'm not quite sure. Okay, I'm drifting because I'm homesick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It seems to me that 0 to 15 would be a natural kind of, size. Probably should have made it a little bit bigger, but too late now. There's number 1, number 2, number 4. Q3 is 10, and 13 is about here. And you're done. Based on what I said earlier, and you have to be a little bit generous with this answer. Skewed left, skewed right, or symmetric? You have to pick one. I'm forcing you. Out of those 3, who are you picking?
Skewed right.
Yeah. Would you agree big box, big tail? Well, let's say bigger than the other box, right? And bigger than the other tail, right? That's enough to make you skewed right. I've no idea what that is indicating, except that the data is skewed right. Are we comfortable now about 5-figure summary, draw your box plot, call it good, right? So let's show you what that looks like in the homework. And you'll see that the way the homework gets you to do it is basically they give you 4 pictures and you pick the right one. Now, if it's a small data set, as it is in question 4, can you probably do that in your head without going near a calculator? Would you agree? Well, let's try this one out. I'll do the easy ones because I'm making my life easy. 2 is the smallest, 10 is the biggest. Now, as I count this data, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there are 9 numbers. So which one of those numbers is the middle one, the median?
7.
Right, now I'm going to highlight that 7. Isn't that actually going to get, the wall's going to get built over it? Can you now see that there are 4 numbers to the left and only 4 numbers to the right? And when it's an even number of numbers, don't you sometimes have to think a little bit harder about who the middle one is? So let's look at this side. Would you agree that there's 2 5s in the middle? Would you agree here on the small side, there are 2 5s? So the middle, because it's the same number, is 5. What would be the, let's put that in. The median is 7. What would be Q3?
$8.5.
Isn't it 8 and 9 in the middle? What do you do when there's 2 numbers in the middle? You average them out. In this case, you're going to have to average them out as a decimal, but that's fine. 8.5. Now, what does the picture look like? It's one of those guys, and you pick it. And, find the interquartile range. Everything you need to know is there. Can you remember the calculation to get interquartile range?
3.5.
Correct. Q3, take away Q1, and you're done. Looking good? No. In question 5, here's a set of data. Would you agree that data is probably better put into your calculator and get your 5-figure summary and then draw your picture, and then one of these pictures is the right picture? Now, why would I do it in my calculator? Well, look at it. Aren't all the numbers all jumbled up? So when you have to rewrite them on paper anyway in order, just be able to do it. So plug it into the calculator, 5-figure summary, do a quick sketch, look at your sketch, one of those pictures is the right one, put a little dot beside it and you're good. Here's a tutorial example of the same thing. Here's another example of the same thing. Horribly big one. And then we get to, we're almost finished. Then we get to question 9. Here is the worst data set you could probably do. Even on a calculator, isn't that getting a little bit too big? But we have a lovely little guy here called salt. So when I click on salt, you're going to see this. And I am going to go and hit descriptive statistics. And if I scroll a little bit to the right, can you see that the last 5 numbers are my 5-figure summary? And I could, if I wanted to, couldn't I use those 5 numbers to draw my box plot and then go back and look at which picture is which? Right, just make it myself. Or if I felt lazy or efficient, instead of doing the descriptive statistics, couldn't I do charts and graphs? Do box plots? Choose the variable. And here it is. The only problem, and it's not a big problem, it's just a little bit awkward. Do you know that these guys have been done vertically, not horizontally? So you'd have to turn your head on the side there to get a view of it. Yeah, it's not fun, but you could do it. And then you would just return back to the question and pick the right one. So I would probably just do the 5-figure summary bit and just do my own sketches, just less hassle. Has anybody seen, before we go and look at some more questions from there, has anybody seen box plots in their career or anywhere? Is this the first time you've seen this particular?
I see box plots on Canvas in like the grade book.
Ah, so they're what? Are they taking all your various homeworks and scores and doing a little box plot of it?
For like every assignment on most of my classes, it shows you like how you compared to all the other students.
Which is either
I mean,
depressing or exhilarating, depend on the class, right?
yeah.
I don't use Canvas at all for anything to do with grading. So if there's a box plot about any of you on Canvas, I don't know what it would contain. Zeros, probably, right? Our course isn't everything that we do, numerically at least, grading on WebAssign. So you'd have to go to WebAssign to see it. Okay, but my brain was thinking for a moment. It's a scary thought. I do that occasionally. You are probably one day, I'm assuming, going to be interested in retiring, and you're going to hopefully have a job that has a pension and has again a saving scheme for your retirement, and you may choose to do stock exchange. And if you go looking at stock exchange, you will see all sorts of weird looking data that looks like this. And I think they call it something candlestick. It's a term I'm not familiar with. So you will see it there. You may well, if you're into nursing, see a similar thing when they are talking about a clinical trial. So I'm going to pretend to make a box plot about the benefits of a new medication. And the data is collected, and it looks like this. And rather than me do all the numbers, I'm just going to tell you that that's 2, 7, 9, 11, and 15. Now, imagine this is a blood pressure medication, and these numbers represent the percentage reduction. So you get measured before you got your treatment, maybe a couple of times, and your blood, you know, your systolic number is whatever it is. And then you take this medication and you get it treated. And this is all the people in the clinical trial. Well, some of the information I can get off that right now is that typically, doesn't someone who uses this medication, don't they get typically about a 9% reduction in their blood pressure? And we're assuming that's what you want, right? You want to reduce their blood pressure. For a few, maybe only one person, wasn't there a 15% benefit? For a few, maybe only 1%, it was almost negligible, right? I mean, it knocked it down a little bit within the realms of just radiation. And lastly, 50% of them, right? The middle chunk of people had a reduction somewhere between 7 to 11%. So if you were advertising this drug and you were advertising it honestly, you might say something like, we have got a new blood pressure medication which is guaranteed to reduce your blood pressure. 50% of our people got between 7 and 11% reduction in their blood pressure. Now, let's suppose that there's a competing company out there and they're doing the same thing, right? They're doing their clinical trial. Only this competing company, their data look like this. Which medication is the best? A or B? Which did the best reduction in blood pressure for the vast majority of people compared to the other one?
A.
Yeah. Well, I guess I could have made my scale a little bit more accurate, but the numbers are enough to see. Can you see that in this case, the best you're ever going to get is 6? Weren't at least 3/4 of the other people getting 6 or more? And in this case, only like one person's going to get 6. So this would be considered a better drug than that. And so if your doctor had information about both of these medications and he had a patient that required a reduction in blood pressure, I would hope that they would choose medication A to give their patient rather than medication B. Now, would B do some good? Sure it would, right? It would reduce it at 2 or 3 or 4%. But if you give them this, isn't there a better chance it might be 6, 7, 8, 9, 10% reduction? And we're assuming that you want a big reduction in their blood pressure. So that's the kind of information that you might receive. You might see it like this. Are we good? Any questions before I move on? So I'm going to have to do a little, what the heck's going on here? Okay, if you can bear with me just for a few seconds. There we go. As I say, we've covered quite a lot of this section already, so that's a good thing. So that, I believe that's where we were last time. So, oops, too fast. Question 10. What you have here is box plots of insurance premiums. So I'm just going to make it bigger and tell you what the writing is, because you won't be able to see it once I do this. Right. So a nice big picture. You know, if you, this is a particular subgroup of people. It's a married couple with one child who's 17 years old, and they looked at how much it costs them to insure, right? Insure their cars, I'm assuming singular car. And these are the data that were collected on a large number of people from 3 different states. So if you're in Texas, you might pay as little as that number, although I don't know what that number is. That's the smallest, right, all the way to the biggest. And here's Pennsylvania, and down here is California. And so what we're going to do is how we can look at these and just decide on general truths. Which one of those 3 states did someone pay the highest insurance premium?
Pennsylvania.
Right. Isn't it that guy right at the end? Look at these 3 states. If you want to compare them in a general way now, rather than just who paid the most, the best number to do that would be the median, right? The Q2 guy. So use the location of that middle line inside the box, right? The middle line in the box. Use its location to do the next question. Which of those 3 states do you typically pay less insurance for?
Texas. Texas.
Agreed? Texas. I see some nods there. If you're not sure what's happening, do you see this middle line on Texas? That's the typical, you know, average kind of amount that you pay in Texas for your car insurance for that particular kind of family. Now, if I do that line vertically, would you see it's smaller than this guy? In fact, if I asked you to put it in order, wouldn't Texas be the cheapest? California would be second, and Pennsylvania, by a wide margin, would be the most expensive. And so you're looking at the same kind of people, right? A married couple with a 17-year-old child insuring themselves to drive their car, right? Yet, look at the differences. That's kind of interesting. If you did Britain, Scotland in particular, but see if you did Britain, there would be virtually no difference between somebody in Strathclyde and somebody in Angus. If you don't know what they are, Scotland's broken up into districts. And the reason there'd be no difference is, see the insurance company that you get in Strathclyde isn't the same insurance company you get in Angus. In other words, it's a national insurance company. Now, Scotland's small enough that there's not a lot of difference between one bit of Scotland and the next. And I asked my other class, and they came up with some interesting ideas. Why is Pennsylvania so expensive? Because maybe somebody here actually knows what Pennsylvania is, and maybe say, yeah, I've lived there, I know why that's what it is. Last chance. I'll tell you what they told me, it was quite convincing. The weather in Pennsylvania is horrible, especially in the winter, and bad weather causes accidents, and so maybe there's more car accidents in Pennsylvania, and so the insurance premiums are higher. I don't know if there's any truth to that, but it seems reasonable, right? If Hawaii was in this, where do you think Hawaii might be for insurance? There was a homework question where they talked about how expensive it was to live in Maui, Hawaii. And wasn't the answer, it's extortionately expensive to live in Maui? And almost always when a place is extortionately expensive, isn't everything extortionately expensive, even when it doesn't need to be? I can understand why milk might be expensive, because you probably have to fly the bloody stuff in because there's not enough cows, right? I can understand why certain vegetables and fruits might be expensive, because if they don't grow them, it's expensive to transport them. But there shouldn't be any reason for insurance to be expensive, really. So how do they get away with that? They get away with it for the same reason lots of things people get away with. Aren't insurance companies going to charge what people are willing to pay? So if you live in a really expensive area like New York, I guess, would probably count as that, wouldn't you probably pay higher insurance premiums because everything costs a lot of money? But then again, everybody gets paid a lot of money, hopefully, and so it's not that bad. The worst thing you want to do is live in a state where everything's expensive but get really poorly paid job. That would be the ultimate bad combination. And before we finish on this, because we're actually pretty much done with one more question after this, just a little reflection. I've been told that one of the things that people in California do when they come to retire is that they sell their house in California, if they own one, obviously. And then they move to places like here, where they can buy virtually the same sized house, but for half the price. And that difference in money is what they retire on. Have you heard that kind of thing? Yeah. So we're in the wrong state. We should be living in California right now, so that when I retire in 5 and 6 years from now, I could sell my Californian house. Because I've seen TV programs. Doesn't a 2-bedroom, 1-garage house go for some ridiculous number like $500,000? And it costs you about $120,000 up here for the same looking thing. That's what I should have done. But it's too late now, right? Okay, last question. Some data sets include values that are so high that they stand apart from the others, and they're called outliers. Right? Now, we had a test for outliers that used, remember the Chebyshev thing, the 2.5 standard deviations away from the mean test? Remember that? Well, there is a test that you can use that you use with your 5-figure summary. And I'm going to write it down and then I'll do an example. So we have a lower limit, and it's Q1, take away 1.5 interquartile ranges. And then we have an upper limit, and it's Q3, add 1.5 interquartile ranges. The good news is that that is standard. That's every textbook I know does this. I'm sure I mentioned last time that this textbook does the 2.5 standard deviations, where everybody else that I know does 3. But this one, at least they're consistent. Now I'm now going to return, and we are going to do a little test on this. We're going to have a data set, and we're going to see whether or not a particular number really is an outlier, or it's just kind of big. Now I'll keep the data set nice and small, that way we can do this pretty quickly. So it's going to be 21, 23, 25, 27, 29, 1, 2, 3, 4, 5, 6, 7. That's good. Let's change that last one to 57. So if I just superficially look at this data, would you agree that the 21 is not that significant? It's right next door to 23. So I think everybody would be quite comfortable with 21 just being a normal data point. Now, how about this guy at the end who is 57? Would you agree that that's a fairly big difference? But the point is that we don't want subjectivity to come in, because Hawley might look at it and say, yeah, I see an outlier. And then Denise says, nah, it's kind of big, but I don't think it's big enough to be an outlier. Right? You see how that's subjective now. You're just doing what your gut feeling is telling you. That's not good statistics, because then how do you know what truly is an outlier, I guess? So using this data, it won't take me long because hopefully I picked nice numbers. Would you agree that that guy in the middle, number 27, would you agree he is Q2? Okay, what number is Q1? Which one of these is the Q1?
23.
Great. And on the other side, we'll circle around it. Which one of these three numbers is the Q3?
31.
31. Would you agree that's very easy? Oh, by the way, doesn't that one kill the guy in the middle and you get 2 3s? Now, I need interquartile range, so I'm going to calculate that. So 57, take away 23, that's 34. Okay. Now, the guy they're calling the lower limit.
I thought in
Sorry.
our quarter range, Q3 would have been the 31
Oh, God in Himmel.
minus 23.
Well, I'm glad somebody's paying attention, because I certainly wasn't. But that's a good sign, because the fact you knew that means that you understand what I was talking about. So I like that. Right. So I'm glad you caught that, because this would have screwed up the next piece of the process. The lower limit then is Q1, take away 1.5 interquartile ranges. And Q1 is 23, take away 1.5 times 8, which is what, 12. 23, take away 12, gives me 11. So if you imagine my number line with ages, on this side we've got 11, right? That's the lower limit. So anybody's age who's less than 11 would be considered an outlier. That's how that works. Now we need to do the upper limit. Wish I hadn't made that mess, but I can do it. The upper limit is Q3 add 1.5 interquartile ranges. And Q3 is 31. Add basically the same number, which is 12. And that ends up being 43. So over at this side, we have 43. Any number in that range, anybody who's 11 to 43 years old is just a normal kind of number spread for this data. Would you agree then that 57 is an outlier? But can you see now we've got an unbiased way of, yeah, you're an outlier, or no, you're not? Because won't this calculation give us a boundary where everybody who lives inside it is safe, they're not an outlier, and anybody who's bigger or less than it is considered a potential outlier? Now, you might